Welcome back to the second TouchDesigner project with Arduino. And in this one, we're going to play with another type of output, the servo motor, which is also a very easy way to play with Arduino and TouchDesigner. And in this exercise, we assume that you have already installed the fermata library into your Arduino board. So the one I'm also using the Uno. And you use the Arduino software to upload your standard fermata library over here. And in order to play with the servo motor, you have the 3 pins. So the first one is the red one, usually is the 5 volt. So I insert it in the 5 volt. And the other will be the ground pin that you insert it into the ground pin of your Arduino. And the last one will be the signal pin that you insert into any of the pin that come with the power, that is the PWM. I use the pin number 9 over here. So this is the connection that I use with the Arduino board. And the second thing that you're going to set up with your TouchDesigner. And as usual, we create the project folder with the name like test servo. Okay, and I'm not going to use any external media. And I tidy up this one and find the fermata library from the palette browser under the tools, and then drag it over here. So what we are going to do with this one is I try to make use of the video, that is the video device in, and do something like the motion detection, and then convert the horizontal movement in front of the camera to drive the movement of the servo motor. So you can have something like that. When you move toward the left hand side, and this one will turn towards yourself, and when you move in the opposite direction, it will always follow you. And then this is our intended project. So the first step is set up the fermata, and using the correct port of the USB modem, and then we make it active. And then after that, we can query your library, and then to check with all the status. What we would like to do is to change the pin mode of number 9, the one we are using. Yes. And this may happen a few times, that when you click on those query options, that it may have referred to the correct pin alignment, pin allocation. And in the pin mode of number 9, we choose servo, and you hear something from your servo motor movement. And then to make sure the pin number 9 is connected, and then we go to the pin value. So the default one will be like 0. So this is the servo motor. And then the next step is trying to drag this slider, and you will see the movement. And because of the chip motor we are using, so the value from the slider supposedly to be 0 to 1. but when it's supposed to something like 0.6, 0.5 something, it's already go to the maximum of your movement. So this is something that you can also cater for in your design. So this is the motion that you have. Okay. So this is the hardware part. So the next part we're going to do will be the software. We use some of the skill that we have done many weeks ago that by choosing a video device in and then flip it horizontally. And store it in a cache. That is a temporary storage. And also reduce the number of the cache size in order not to waste the storage. And then using the cache select, drag it over here. And to pick up an index smaller than 0, like -4. There will be 4 frames before we make the comparison between 2 of them by using difference. So this is the difference image between the 2 frames. And we can also use monochrome, but we are not using the color information. That is the monochrome. And even we can use threshold, the pure black and white, like this. And as we mentioned before, we can alter the threshold value such that we can have more or less white area. So the white area actually that's where the movement is. We have done before by using block track. Which give you information like this. So the square actually is located where your major motion is. And in order to obtain the information, we make use of info chop, which is here, and then you can just drag it to the operator, and it will give you information about your motion with the block 0 and block 1. Because we are using the education license, so we only have 2 blocks for the tracking. So we'll just make use of the block 0 and use only the horizontal value, that is the block 0 : U. Okay, and then we do a select. And then just track the BIO B0 : U. And we can also rename it to X. So this is the X value, which then will move corresponding to your horizontal position. And you might also notice that it will disappear when there's no motion. So in order to maintain the position, we have done by using feedback. Connect it to the feedback. And then this value will maintain, even though you just sit there without any movement. And in order to play safe, there's one initial value that you can use. So we can use something like constant to give an initial value X. So we need to rename it at X and give it an initial value of 0.5. So 0.5, that means center of the screen. So that means when you have no movement, when you switch on the computer, open it, this moves. So the position is already in the center of the screen. Okay, So once we have this value, we can fine-tune by doing a filter to make it a little bit smooth. It's something like Gaussian glue that we have in Photoshop. And this value will now be ready for you to put it into the servo motor. And we have also demonstrated that the range of the slider that we control the servo motor is a little bit limited, rather than extending to the 0 to 1, that is something more or less like between 0 and 0.5. So we can enhance this by changing the range. Like the original one is 0 to 1, and the true range can be something like 0 to 0.5, that give it or restricting the output value. So now, if you want to, you can also connect it to a node chop, which give you more flexibility. And then you can go back to your formatter, that is the value of your servo motor here. So instead of using our hand to move the slider, we can always use this number returned from the motion tracking and turn on the wheel icon and drag it over here and export to the chart. So once you have this one, you can perform something like this. So this is your motor. So when you're moving around, so you can turn it into a different direction. So you may end up by this thing turning towards yourself. So this is the thing that we can play around with by connecting the motion of yourself. So this movement in front of the camera. And if you want to have a better feedback, you can always add something like visual feedback from your camera, so that we have done before in the past. So we can have a very quick review by choosing like rectangle and make it the size of our screen with the custom resolution. And then for this rectangle, we can make it really narrow and long. Something like this. And if you want to, we can change the color. So we can do another transform to change the translate for this one later. And when we go back to next step one, will have a smaller value, but we can use this one over here and then do another math to convert the number. So if you remember, the value for your motion left to right to right is 0 to 1. But your position of that vertical line will be minus 0.5 to positive 0.5. So we can use this range of conversion, minus 0.5 to positive 0.5, and then send it to a node chart. And then we can drag it to the translate. So now when we move around, we have something like this. And of course, you can combine it with your video image by using composite. And then finally send to the output with the proper operator over or under, depending on the sequence. So that will be your display, so that we can more or less detecting the motion around here. And at the same time, when you move, so you take a look at your motor, something like this, something like the camera. Because my hand is also moving around here, so I make a bigger movement. And I move around here. So that movement in front of the camera will trigger the movement of this particular thing, which is a little bit obvious, so you might need to hang it something like this in order to make it synchronize with your movement. So this is the logic and also the ideas about this project is using Arduino servo motor and motion control, motion detection with your video camera in TouchDesigner. Okay.